In this lesson, we will be introducing the selection sort algorithm. Let's begin by creating a new project. Go to the File menu, choose New Java Project, and we'll give our project the name Selection Sort, and then click the Finish button. Within the Project Explorer, we'll open the project, right-click on the SRC folder, and choose New Class. Now, we'll also give our class the name Selection Sort, and be sure to check the checkbox for Public Static Void Main before clicking the Finish button. Now that our code window is open, we can minimize the Project Explorer and delete this unnecessary line, and then delete the comments outside the main method. Within the main method, we can use the comment line that's already there to put our name in the code. Now, to begin, we're going to need some data to sort. We'll do that by creating an integer array, which we'll call ARR, and we must create the array. In this case, we're going to create an empty array with 5 elements in it. Next, we're going to create a for loop to iterate across the entire range of array values. We'll increment our iterator variable, and now we're ready to begin assigning values to each element of the array. We want our array, our first element within the array, to have the highest value, and then each succeeding element to have a lower value, so that our list starts out in a non-sorted order. So we're going to use r.length and subtract the current value of I. Because I starts out at 0 and r.length will start out at 5, the value in the first element will be 5. When I becomes 1, r.length is still 5, so the next value will be 4. Next, we're going to want to output the current values to our console. So we're going to write a method to make it easier for us to do that, since we're going to want to do it more than once. Our method is going to be public and static, and it's not going to have a return type, so it will be void. Next, we're going to list the name of the method, which we're going to call listArrayValues, and then we're going to list the parameters for our method. The first parameter is going to be a string, which will be simply a label that will come before each element in the array. Next, we need to pass the actual array that we want to print, which will be an int array. We'll call it ARR again. Within the method, we're going to now proceed to print each value within the array using another for loop across all of the elements within our array. And now we're ready to write our system.out line to print our values to the console. Each line will start by printing the label, followed by, within quotes, a left square bracket, followed by the value of the iterator variable I, followed by a right square bracket, and then an equal sign. And now we're ready to add the actual array value that we want to print. And our method is done. Now, before we actually call the method, let's indicate to the console with a print line that these are the values of the array before our sorting algorithm does anything. And then after that, we'll call our listArrayValues method. Now, the first thing that we have to pass is a label, which is going to be the name of the array. And then the second thing is the actual array itself, which is also ARR, but without any quotes. Now, let's quickly run our program and see if it's working properly. As you can see, we have before, ARR of 0 is 5, then 4, then 3, then 2, then 1, which is pretty good. That's what we wanted. Okay, now we're ready to begin actually trying to sort this array into order. The first step can be to simply take the lowest value in the array, and if we look at our values again, the lowest value is stored at position 4, and swap it with the first position in the array, which is R of 0. So when we're done, we should swap 5 and 1. But of course, we don't automatically know where 1 is in the array, or if 1 is in fact the lowest value. So the very first step is going to be to write an algorithm within our algorithm that will find the lowest value. So we're going to essentially write a find minimum algorithm. We're going to have an integer value, which is going to have the minimum index, and it will start out at 0. Next, we're going to have to write a for loop that iterates across all the values except the value stored in min index. So I is going to start out with a value equal to the min index plus 1. Next, we're going to have I continue as long as it's less than the length of the array, and then we're going to iterate it. Now, within our for loop, we simply need to check to see if each element pointed to by I is less than the value stored in the element pointed to by min index currently. So we write our conditional statement. If R of I is less than R of min index, well, then we're looking at a new index, a new minimum. So we'll say min index is equal to I. And that will find our minimum value and store it in min index, or rather a pointer to the minimum value. So now what we want to do is write the code to swap the values in the array at position 0 with the value stored at position min index. So first we're going to create a temporary value, and we're going to use it to store what is at R of 0. And next we're going to take R of 0 and give it the value of R at min index. The final step in the swapping values mini algorithm is to say R of min index becomes equal to the value stored in temp. What we've just done is we've swapped the values with R of 0 and R of min index. So now it would be nice to see the results of our algorithm. So we're going to do another system out, indicating that this is after our algorithm. And we're going to, once again, list array values R and R again. Okay, let's see how this works. Now, in our before, we have 5, 4, 3, 2, 1. In our after, we have 1, 4, 3, 2, 5. So we can see that the values at 5 and 1 have been switched, which is good. That's the first step in getting this list in sorted order. The question is, what would this algorithm, or what should this algorithm do next? Well, if we wanted to continue to sort this list, what we would want to do is find the next lowest value in our list. And since the first item in our list has the lowest value, we could start by assuming that the next element in the array, which would be stored here, is the minimum, and then hunt through all the remaining values until we get to 2. At that point, we switch 2 with 4. and now the next elements are in sorted order. And if we continued that process through the entire list, our list would be fully sorted. So let's think about how we do that. As usual, we're going to want some kind of a loop, and we're going to make it a for loop. Now, we have to come up with a name for the variable in our for loop. And what this variable represents is where in the list we are currently swapping values. In the prior example, we started by swapping the minimum with what was at position 0. But now, we're going to be doing each new value in the list. So swap index will be the way that we keep track of it. So we'll keep going as long as swap index is less than r.length, and we'll increment swap index. Now, the question is, what goes inside the for loop? Well, the complete algorithm for finding a minimum starts here, then we swap the values. So we can sort of say that our algorithm so far ends right here, because after that is simply printing the results. So we'll put all of that inside our for loop and indent it to indicate that it's now part of the for loop. And believe it or not, we're almost done. Now, instead of min index being 0 each time, we want min index to start out with the value of swap index, which will be 0 the first time. It's important to note at this point that I will start with the value at min index plus 1. So the first time through our loop, swap index is 0, so min index is 0. And we'll loop through elements 1 through 4. The second time through the loop, swap index becomes 1, and therefore min index becomes 1. And so we will sort through elements starting at 2 going to 4. Alright, now at this point we are basically ready to run our algorithm and see if it works, except that each time we'd be swapping the element at position 0, when in fact what we want to do is swap with the element at swap index, because that keeps track of the variable or the point in the list we're currently operating on. Okay, now let's run our code and see what happens. If I look at my before, I have 5, 4, 3, 2, 1, and my after, I have 1, 2, 3, 4, 5. So our algorithm worked. Let's take a closer look, though, by viewing this code in debug mode. What I'm going to do is put a stop within the for loop here, and then put a second stop when it comes time to swap the contents of our arrays. Now I'm going to run this in debug mode. Very well. Okay, now I've arranged my Windows sum so that I can see all the values of the array currently, as well as some key variables. Now I can see that min index is about to get the value of swap index. So min index is currently 0, which means that the computer is essentially assuming that 5 is the lowest number in our list. And if we follow this algorithm once, all the way through, stepping through it, we can see that now r of I is looking at 4, which of course is lower than 5. So that becomes the new minimum. And that process continues. Min index is now 2, and min index is now 3. We're almost through. Min index is 4, and our loop is done. So we're now ready to swap. Let's look at the values in swap index and min index. Swap index is pointing at 0, which means element 0 in the array, and min index is pointing at 4, which is element 4 in the array. Those elements have 5 and 1 respectively. And so now we're going to swap them so that 1 becomes 5 and 5 becomes 1. And as you can see, that's what has just occurred. Alright, at this point I can speed up the process by hitting the resume button instead of stepping through each element to see the process complete. So right now, I'm going to hit resume. Min index is now 1, and therefore, swap index is now 1, which means that min index will be 1. So the algorithm will now go through the list starting at position 2, looking for the next lowest number, which of course it will find here at element 3 in the array. I'll hit resume again, and I'm about to swap values. Which two elements am I going to swap? Well, swap index has 1, so it's going to swap the value stored at element 1, which is 4, with the value stored at element 3, which is 2. And that is, of course, what we want, because 2 is the next lowest number. Now we can see that our list has suddenly become completely sorted. However, our routines are not done running because our for loops aren't done. How many more iterations of each loop will it take to complete? Well, it's going to swap 3 with 3, and then swap index is 3, so it's going to swap 4 with itself. As you can see, the swap index and the min index are both 3, which means that it's going to swap the value 4 with 4, even though they're at the exact same position. And for the final iteration, it's going to look at element 4 in the list. And of course, since 5 is both the minimum and the maximum, it's going to swap its value with itself. Okay. And now our algorithm is complete. So I'll click on the Java perspective button to get back to our code, and we have essentially written a complete algorithm for sorting a list of integers. What if I want to see it sort a list of more integers? I can change the number of integers in the list and run it again. And as you can see, that list is also sorted into order, just like the first list. This will work with any number of integers as long as your computer has enough memory to hold the list. Okay, that completes the introductory lesson on sorting using the selection sort.